Everyone. A very good morning. Dear authors and invited guests, welcome to Technical Session 5D. Myself, Richa Shah, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the ninth International Conference on Information and Communication Technology for Intelligent Systems ICTIS 2025 held in Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom today and tomorrow, that is the 5th and 6th of April. I hope you all enjoy the knowledgeable interactive sessions through the day. So, in this session, we'll have 10 presentations. Each presenter will be given 10 minutes for their presentations, and after 2 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, you can write it to me in the chat box. So before we start the session, I would like to introduce you all to our session chair. Dr. Paras Kothari. Sir is a professor and head at Gitanjali Institute of Technologies, Udaipur. Sir is the session chair for our session today. Welcome, sir. Moving on next, I'd like to start with the paper presentations. I'd like to call Mr. Kishan Gadbi for his paper titled Adaptive Microgrid Integration and Distribution Generation Optimization for Enhancing Distribution Network Resilience and Minimum Power Loss. So please can you start with the presentation?
Oh, okay. Am I audible to all of you? Hello, ma'am.
Yes, sir.
Okay, ma'am.
So your screen is also visible. You can start.
Hello.
Yes, sir.
Am I audible now?
Yeah, you're audible now.
I share my screen. So sorry for inconvenience.
Okay. Yes, sir.
My screen is visible to you, ma'am?
Yes, sir. You can start when you're audible.
Okay, thank you. Good morning, everyone. My paper title is 502, and the paper title is Adaptive Microgrid Integration and Distribution Generation for Enhancing Distribution Network Resilience and Minimizing Power. This paper will be presented by Kishan Gadwi, and my co-author is Ms. Sefali Talati and Mr. Ajay Mishra. An overview of this presentation: introduction, methodology, result and analysis, and conclusion. Introduction. The study of resilience of distribution network are important because distribution network has very important place in the power system, since it is the primary linking between bulky power and consumer. The distribution network with the integration of microgrid present a viable route to sustainable energy solution. The occurrence is high risk and low frequency event and its significant impact on distribution network. And resilience distribution network can withstand, adjust to, and quickly recover from interruption. The distribution network resilience is designed to withstand the extreme event that are high risk, low probability, such as several natural catastrophic and man-made assaults. Here's the definition of grid resilience from reputed organizations like Department of Energy: the capacity of power system and its continuous part to endure, adjust to, and quickly recover from disturbance calls the distribution grid resilience. Factor which affecting the distribution network resilience, like the severity of low frequency high risk event, severity of power infrastructure damage, and unavailability of level of human and material resources. And this is the typical distribution network resilience triangle, as you can see in this figure, where TE time the low frequency high risk event occur in the system, and the system behaves after the low frequency high risk event. The real recovery of the system is given this line, and The approximate recovery of the system is given this line. Now, the methodology for this paper. This work offers the framework for resilience to high-risk low-frequency event in distribution network. For this intention, we use the traditional resilience index like loss of load probability and expected demand supply are given below these two equation, and using the Monte Carlos approach, we determine the likelihood of creating the microgrid in each scenario, as well as the resilience index and the number of hours it takes to restore the distribution network following the low frequency high risk event. We employ the forward backward sweep approach for optimal power flow in order to calculate the loss of load, and also MATLAB software will use for all simulation purpose. Now, this is the typical flowchart of proposed algorithm where we first build the low frequency high risk event model in the system. And we set the Monte Carlo simulation and we check the topology after the low frequency high risk event occur in the system. When the several part of grid area which connected to the grid, then we solve the optimal power flow for that area. If the optimal power flow is feasible for that area, then we update the distribution network resilience. If the optimal power flow is not feasible for that area, we increase the load curtailment for that area and we solve again the optimal power flow for that area. If the several part of the area of the network is not connected to the grid, then we check the topology for formation for the microgrid. If the microgrid are not formation because of the there are no present in the distribution generation for that area. So if the generation are not present in that area, we update the distribution network resilience. If the microgrid are formed, then we solve the optimal power flow for that microgrid, and if the optimal power flow is feasible for that microgrid, then we update the distribution network resilience. If the optimal power flow is not feasible, then we increase the load curtailment for that area, and we again solve the optimal power flow for that microgrid area, and we update after the optimal power flow result, update the distribution network resilience. And for this purpose, we use the IEEE 33 bus, as you can see in these slides, and we employs the four different cases, where the first case where these tie switch are not present in the system, where we also the distribution generation are not present in this system. And if the low frequency high risk event, what kind of effect in this network will evaluate. And the case two, where the distribution network is tie switch, these tie switch are present in this case and no distribution generation are present. And the case three, where distribution network is a tie switch and the randomly selected distribution generation size and placement are present in this system. And the case four, where distribution network is tie switch and optimized selected distribution generation size and placement using the genetic algorithm are placed in this system. Now, result and analysis. So for the case one, where the tie switch are not present, after the low frequency high risk event occur in this network, the server transmission line outage due to this event, and as you can see, the highlighted part of the area which supply through the substation distribution substation of the network, and outcome of the Monte Carlo simulation and proposed algorithm given in this figure. And as you can see, the low frequency high risk event occur in this is that time the system no microgrid are forms, and the system take 3 to 4 days to return its initial configuration, and the system delivers only 10% of the active power of the network. Now, case two, where the distribution network has tie switch and no distribution generation are present. So after the low frequency high risk event, the server transmission line goes out, and the highlighted part of this area will supply through the substation, distribution substation. And the outcome of the Monte Carlo simulation are given in this figure. As you can see the tie switch is strengthen the distribution system. Also, the no microgrid are formed in this case, and it's take 2 to 3 days the system to return to its initial condition. And we can see that tie switch are provide some assistance in enhancing the system resilience. However, the system power quality is a problem because it is a radial system, no longer as mesh system for this case. Now the third case where the randomly selected distribution generation and size are given in this table, and 3 microgrids are formed after the low frequency high risk event occur in the system. And the typical outcome of this proposed algorithm, where the three micro load curtailment occurred because the distribution generation is insufficient to supply the electricity to the microgrid, and the system resilience to high risk low frequency event restore the system its initial state just take 1.5 days. And this is the fourth case where the optimized distribution generation and size and placement are present in this table using the genetic algorithm outcomes, and where 3 microgrids are formed, as you can see in this figure. And this is the typical outcome of this Monte Carlo simulation method, where this system is more resilient to high risk low frequency event. Restoring the system its initial state just take 1 day. There is no need for load curtailment in this setup because the 100% of load has been supplied following a low frequency high risk incident. And this is the expected demand supply index for this IEEE 33 bus. As you can see in this figure, the case 3 and case 4 is a highly expected demand supply after the low frequency high risk event occur in the system. And this is the active and reactive power loss in each case of the system. As you can see, the case 2 is a higher loss present in the system because the system is a radial, no more mesh condition. So and case 3 and case 4 is a viable solution for enhancing the microgrid grid resilience and minimizing the power loss. And conclusion for this paper, the low frequency high risk event has increased in rate, which makes the distribution network resilience more difficulty to maintain. The approach for assessing the resilience of electrical distribution network with an integrated microgrid in the case of low frequency high risk event in present in this study. And in the case 4 is offers a 100% load restoration following the low frequency high risk incident and the best microgrid Iceland ability. And the additional, it's demonstrate the distribution generation and Icelandable microgrid not only assist the distribution network, but also boosts its resilience. Thank you so much for peacefully listening.
Thank you for your presentation, sir. Any questions from the session, sir?
I'm sorry, this time I have connected very late and I just got through. Nice presentation, whatever I read, and this time I have no question for this. Thank you.
Sorry, sir, can you recall? I cannot hear.
Am I audible?
Yes, sir. Now you are audible.
So it's a Gadvi Kishan, right?
Yes.
So I was saying that nice presentation it was, and because I regret that I joined the late and I could not go through the entire presentation, but this time I have no query. Please go ahead, proceed. Thank you. All the best.
Thank you so much. Thank you so much.
Over to you, Richard.
Can I end my presentation?
Yeah, please do.
Yes, sir.
Thank you.
So, moving on next, I'd like to call Mr. Vedant Sawant for his paper titled Autonomous Drone Control and Live Video Streaming Using MAV Link and GS Streamer with a Raspberry Pi companion computer. Sir, please can you start with your presentation?
Yeah, ma'am. Just a second. Is my screen visible?
Yes, sir.
Okay.
Okay, so hello everyone, and thank you for joining us today. I am Anaga Thakur, and with my teammate Vedant Sawant, Rahul Deshmukh, Aryan Singh, I am excited to present our project system titled Autonomous Drone Control and Live Video Streaming using a Mavlink and G Streamer with a Raspberry Pi companion computer that bridges autonomous drone control and a real-time video feedback using an open source technologies. Before we begin, I would like to express our sincere gratitude to Terna Engineering College, Navi Mumbai, India, our mentor Dr. Vrajesh Mehta, and all the faculties and lab staff who guided us throughout this journey. Uh, here is a brief outline of our presentation. I'll begin with a abstract problems background and objectives and system architecture. Then Vedant will cover implementation, result, challenges, and comparison with the existing system and future scope. Our system focuses on creating a cost-effective autonomous drone system that stream a live video while being controlled remotely. We use a Pixoc flight controller and a Raspberry Pi as a companion computer, a Mavlink for a command communication, and GStreamer for a efficient video streaming. We also developed a Flask-based GUI for a user-friendly interaction with our drone. The need for an autonomous drone is rising in a sector like security, disaster relief, and industrial monitoring. One critical aspect in a real-time feedback, especially via a live video, which is usually limited by a high latency or expensive setups. Our aim was to design a system that addresses this concern while staying affordable and modular. Existing drone systems often face issues like high latency, poor onboarding computer, and a manual operation dependency. Moreover, live video streaming is often unreliable, not integrated efficiently. So we aim to solve this issue and drone that offers autonomous control, reliable telemetry, and a real-time video through a lightweight, low-cost setup. Before moving to our objectives, let's briefly compare our approach with existing research, traditional drones control, and a Mavlink with a ROS, making it complex, while we simplify it with using a Python. Existing system methods are RTSP have high latency, but we use GStreamer with a H264 for a better performance. Security is also a concern in a previous study, so we enhance with a Mavlink messaging and optimize with a UDP transmission. Our project has four main objectives. So first one is to enable a autonomous drone navigation using a Mavlink. Second one, we implement a real-time low latency video streaming using a GStreamer. Then third, we ensure secure Wi-Fi based communication for a telemetry and a video data. And fourth one, we developed a web-based GUI to display a telemetry data and allow manual overrides. So here is a system architecture of our project. The Pixoc controls a drone motors and sensors. The Raspberry Pi acts as a companion computer, handling commands, logic, and streaming. A camera module which captures the live video and GPS modules provides a real-time location. This compact system enables both autonomous and a remote manual control along with a live video. So now handle it over to Vedant, who will talk about a software architecture and implementation details.
Thank you, Anaga. Here's a look at the software architecture. The Raspberry Pi communicates with the Pixoc using Mavlink over a serial connection. We use DroneKit Python to send flight commands. GStreamer encodes and transmits the live video feed, while a Flask-based web server serves the GUI that includes telemetry like GPS coordinates and battery status. Let's go how we implemented this. We first connected the Pixoc to the Raspberry Pi using a UART port. Using DroneKit Python, we created an autonomous mission script and also handled manual control through the GUI. For video, the Raspberry Pi camera captures the feed, which is then compressed with H264 and streamed using GStreamer pipelines over UDP to the client. So the testing and results. We tested the system on a quadcopter drone in both indoor and outdoor environments. Autonomous flight missions ran smoothly, and manual override through the GUI worked seamlessly, validating our system architecture. This is the GUI we built using Flask and Bootstrap. It displays a real-time GPS location, altitude, battery voltage, and it includes button to arm, disarm, take off, and return to launch. The video streaming had a latency of less than 200 milliseconds, and telemetry was consistently updated in real time. We also embedded the video stream into the page using a MJEP streamer on a separate route. The goal was to make the interface intuitive and responsive. Some key challenges we faced were ensuring low latency without overloading the Raspberry Pi, dealing with network connectivity fluctuations during outdoor tests, and also synchronizing Mavlink commands and video streaming without interference. We optimized GStreamer pipelines and handled exceptions in the command script to resolve this. In comparison to the existing commercial drones, our system is more customizable, far more cost-effective, and uses open source software. While it may not match high-end drones in terms of range or camera quality, it provides an affordable platform for education, research, and lightweight field applications. Conclusion. In conclusion, we successfully developed a functional real-time autonomous drone system using open source tools. It supports live video streaming, secure telemetry, and manual control through a GUI. The setup can be scaled further and adapted for various real-world applications like surveillance, inspection, emergency response. For future improvements, we plan to integrate object detection for intelligent navigation and also cloud-based access. Also, we are looking forward to improve video compression and multi-drone support. We believe that this project opens up exciting possibilities for the smart drone ecosystem that are both accessible and powerful. Here are some of the references that we supported our project development. We referred to official Python documentation for Mavlink and DroneKit Python and GStreamer. Also, with several open source drone forums and research papers on real-time streaming and autonomous UAV. Thank you for listening to our presentation. We are happy to take any questions.
It was good, Vedanta. I would like to ask, is this your project research paper, or you are working with the model of this?
We worked on a complete model which developed a whole autonomous system.
Are you a student right now?
Yes.
Okay. So, Vedant, in case, what other alternative is there than Raspberry Pi to implement the Mavlink phone?
There are various other boards available in the market, like Navio board. So basically, the overall how the drones work is that a flight controller controls the drone, and this is the traditional approach. Like the flight controller is supposed to control the rotors and all the sensors and like make proper synchronization between them. But what we are doing here is rather than just using a RC controller and a drone, what we are doing is we are adding a companion computer to it. So other than Raspberry Pi, we can add any other small computer which can fit onto the board. We can also make our own customized small computer. But currently for our convenience, we use Raspberry Pi.
Okay, okay. So, did you study what other boards can support, which are the limitations of the Raspberry Pi, or something extra with the Raspberry Pi can be implemented than other
Yes.
boards? Have you
So
go study?
yes, sir. So as we know, Raspberry Pi has limited computing capabilities. So
Yeah.
what we can do is we can there are overlay hats available for Raspberry Pi. Also, what we can do is we can add multiple processing extensions to the Raspberry Pi board as well. For example, we can add a 5G module to it, or a 4G module for LTS communication. Also, in other ways, we can add external power, or else use some higher version of Raspberry Pi, or also of some other boards are available in the market, like Navio board and all. But Raspberry Pi is a good standard board, like it's standardized everything.
Easy available and implementation is there.
Yes.
Okay, Vedanta, all the best. Good luck for your future. Thank you.
Thank you, sir.
Thank you for your presentation, sir. Moving on next, I'd like to call Mr. Daniel for his paper titled Developing an Unmanned Traffic Management Framework for Aerial Systems in Sarawak using Work System Theory. So, please, can you start with your presentation?
Good morning, everybody. My name is
Yes,
Daniel, and
yes, sir,
this
it is
morning,
visible.
all right, this morning I'll be presenting our research, which the title is Developing an Unmanned Traffic Management Framework for Aerial Systems in Sarawak using Work System Theory. A bit of introduction. Unmanned aircraft system, called UAS, according to the Civil Aviation Authority of Malaysia, composed of three components, which is unmanned aerial vehicle, UAV, also known as a drone, the ground control stations, and then the data link, which is the communication system between UAV and GSC. Sarawak, Sarawak is a state in Malaysia, which is located in Borneo Island, with approximate land area of 1,245,450 square kilometers. And the land itself is a very vast network of mangrove forests, thick soil, mountainous terrain, and Thames River network. Now, for logistical purpose, it is very difficult for people in Sarawak to actually deliver goods, as Sarawak is not as densely populated as our counterpart in Peninsular Malaysia. Now, the challenges to access to the remote area include lack of accessible roads, because most of it are, or we are having the dirt road, as some of it are on dirt road, and limited infrastructures, okay, difficult terrain. We can have a mountain, and then a valley, and then the river in the same stretch within 10 kilometers. And then, of course, there are crocodiles in the rivers. So the use of UAV technology offer a promising solution to face to counter these challenges. Now, unmanned traffic management. UTM is a framework specifically designed to facilitate the safe, efficient, and scalable operation of unmanned aerial vehicles. It actually serves as the same as this aircraft tracker that is used by airports throughout the whole world. Okay. Now, so UTM aims to manage increasing drone traffic, ensuring safety, security, and efficiency in the airspace. It may involve a set of technologies, rules, procedures to manage and monitor drone flights. And all these rules and procedures are different between countries. Now, within Malaysia, Sarawak is is sort of a special state where we have certain autonomy on our state. So part of the autonomy will be immigration, land, and certain space on the air, which makes regulations very difficult. And UTM is to enable a shared environment where both manned and unmanned aircraft can safely coexist. Because nowadays, if we fly a drone, then there is no way for other people to detect, especially on the air traffic control, to see that whether the drone is flying or not. So that means we are currently, the Ministry of Transport is really looking into the implementation of unmanned traffic management. So the key aspect of UTM include communication, navigation, and surveillance systems that provide traffic management for drones, akin to traditional air traffic management systems. So the level of UTM is dependent on technological advancements and regulatory frameworks. So each country may have different airspace structures and legal requirements. So nations such as Singapore, Taiwan, China, and Japan are developing their own UTM framework, which are different in own landscape. So development and standardization of UTM systems are being spearheaded by various aviation authorities, research institutions, and industry stakeholders. This system, however, often cater to environment which establish infrastructure, limiting their applicability to regions like Sarawak. So work system theory. So this is a research that is actually grounded on work system theory. So this system theory, which is started by author, is an integrated framework for understanding system within organizations, particularly those relying on information technology. So it is a foundational tool for describing and analyzing IT-reliant work systems. So UTM is actually a set of IT system with a lot of informations, with a lot of components, which I will go through later. So it outlines the system's form, function, and environment, focusing more on the business concerns rather than the IT specifics, because we are using the drones for operations. So the business side of the things are important for us. So the framework consists of 9 elements. Okay, categorizing process, activities, participants, information, technologies, as internal to the work system. And there is an external system which consists of customers, product services, environment, infrastructure, and strategies. So this is the work system framework that we are using to develop our own framework. So the research design, our research actually used a qualitative approach in the great work system theory into developing a main traffic management framework. So work system theories components are mapped to the key elements of UTM system to ensure a holistic design. For data collection, we actually engage various stakeholders, healthcare providers, hospital in Cebu, regulatory authorities, CAM, which is Civil Aviation Authority of Malaysia, Ministry of Transport in Sarawak, and logistic companies. They will be affected by UAV deliveries. So this engagement actually ensures that the research is grounded in real-world needs and constraints, and actually adheres to regulatory standards. Because the framework we will need to be vetted by Ministry of Transport in Sarawak, as well as the Civil Aviation Authority of Malaysia. So we're using focus group to conduct and to assess the intellectual capacity of specific organizations. The qualitative data was gathered via scheduled one-on-one semi-structured interviews. To analyze our framework, we are using the framework model set by Collard et al. And it is actually a suitable tool for supporting thematic, which is a qualitative content analysis, because it provides a systematic model for managing and mapping the data. So the method is suitable for analyzing interview data, okay? Because we are trying to find the themes. So the themes are actually the components. So this is the framework that we have. Okay? So we have the services, major processes and activities, participants, information, technologies. So all these are within the organizations. Okay. Then outside the work system, we have determined all the environments. What are the issues and what are the components and what are our strategies, infrastructures and the strategies. So all of these will be available in the paper. So in conclusion, this work presents UTM framework for main area system in Sarawak, grounded in the work system theory for the delivery of medical supplies in Cebu Hospital. So because we are trying to address our region's unique challenges, the framework offers a structured approach to safe and efficient airspace management, as well as holistic system, whereby we do not miss any of the important aspects in regards of information system. So operation research will focus on pilot implementation and refinement of the framework based on real-world feedback. Okay. And then the successful implementation at Cebu Hospital will motivate its adaptation across hospital and other related industry in Sarawak. That's all. Thank you.
Okay, thank you, Mr. Daniel. Uh, Not exactly related with the research paper. I am having just one query that you are saying that this framework is implemented for the Sarawak, which is a almost zero point 0.1 million square kilometers area. What are the challenges if you want to implement it for a bigger area? Or can you just give me some brief on that?
Now, in Sarawak will be first of all, it's a regulatory problem because we have Sarawak is one of the special states which were given some autonomy on our side, which means a regulation problem. Now we have the land problem. All right. Because Peninsula Malaysia and Sarawak, we are having different body to regulate. So using drone, we need to comply through our Sarawak. We need to fulfill our Sarawak regulatory. If uh, we need to comply to Sarawak regulation, and then we need to comply to CM, which is the federal side. So this is our regulatory issue. The other is the topology issue. Now, Sarawak, although the land is big, but it is sparsely populated, which means the density is not that high. So in terms of infrastructure, we have problem on internet coverage. Because if we are trying to implement this, we will need to have at least a 4G signal, which is easily available in urban area, but not available in rural area. They have only 2G or 3G range, which is not significant enough for us to have a live feed video and to track the drones and the delivery. And then the issue would be the technological issue, which is on the drone. Because currently the battery is the issue, and if we are going for a larger drone, that means with a payload made with the medicine, then battery will be a big issue. So this is the three biggest challenge that we are facing right now.
So operational feasibility is also a challenge, as well as some, how we can say, the authority support is also required for a bigger one implementation, right?
Yes, right. Because right
Okay,
now in
thank you.
Malaysia, for each flight, we have to go for the permit, which is a case by case permit.
Okay. So thank you, Daniel. Thank you very much. All the best for you.
Right. Thank you.
Thank you for your presentation, sir. Moving on next, I'd like to call Mr. Santosh Kumar Petty for his paper titled DPEG-NET, Dual Path Autoencoder with Graph Convolution for Joint Texture and miniaturized feature learning in contactless fingerprint recognition. So please can you start with your presentation?
Thank you. Am I audible?
Yes, sir.
Okay. I hope you can see my screen. Can you please confirm once?
No, sir, we could see click to exit full screen written on your screen. We can't see the PPT.
Okay.
Yeah, now
Okay.
it is visible.
Now it is visible.
Huh.
Okay. Good morning, everyone. So my name is Santosh Kumar. I am from India. So from IIT Kharagpur. So my paper is dual path autoencoder for graph convolution in this miniature extraction in contactless fingerprint recognition. So these are the contents for my presentation. Introduction, related works and research gaps, and method and results and conclusion. So coming to the introduction part, generally
Sorry
if
to
we
interrupt.
want
Mr. Santosh Kumar,
Okay,
can you put it in the slideshow mode?
okay, sorry. Can you see the screen?
No, again, the problem is the same. Click to exit full screen. I think you should exit from the presentation, first presentation, and again you start the presentation. Yes. Now you can go with the slow slideshow.
Yeah, I'm trying to do that, but it is not coming. So is it not showing
No.
again, sir?
Same problem. Same problem is there. Okay, carry on with the same slides. I think you can go. You are using these slides, Google Slides.
Yes, sir. Yes, sir.
Okay, just carry on with this. Go ahead, please.
Okay, sir. Sorry for that, sir. Okay, I'll
No, no
continue.
issue. Continue.
Okay. Okay. So generally, if we want to distinguish two fingerprints, so the most conventional and traditional features are minutia points. So minutia points are the points where these ridges end or bifurcate. So there are other minutia locations also, but these two features where this ridge end or ridge bifurcate, where you can see it from here in the image, so these are the most important part. And another with with this deep learning advancements, so another
Santosh has lost the connection. Richa, are you there? Am I audible?
Yes, sir.
Yes. Richa, I think Santosh has lost the connection.
Yes, sir. We can move on with the next presentation. We
Ha,
can
and
continue the
we will
search
take him
later.
in the second.
Yeah.
Yes.
Moving on next, I'd like to call Mr. Bui for his paper titled Integer Programming for Optimization of Blood Type Consistency in Family Records. Sir, can you please start with your presentation?
Mr. Bui is not available.
Okay. So, I'd like to call Miss Rohini as for her paper titled Mobile Net V3 Shuffle for Leaf Disease Detection, Integrating Lyme for Explainable AI in Multi-Class Classification. Ma'am, can you please start with your presentation? I think Rohini ma'am is also not in the meet.
Hello.
Hello.
Hello. Rohini ma'am can't attend because of her pregnancy. Can I present, ma'am?
Yes, sir, no problem.
Yes, ma'am. Thank you, ma'am. Is my screen visible, ma'am?
Yeah, it is.
Yes, sir.
Yes, ma'am. Good morning, all. Firstly, I will explain what is the topic is about. MobileNet V3 Shuffle for leaf disease detection, integrating Lyme for explainable AI. MobileNet V3 Shuffle is the name of the model proposed by us, which is a combination of MobileNet V3 large and a channel shuffle models. And of course, it is used for leaf disease detection. And we are integrating Lyme for explainable AI. Explainable AI is a subdomain in a AI concept where it is used to improve the trust from the model and the users. It can be integrated in multiple domains, namely MobileNet V3 can be mapped into deep learning domain, and integrating Lyme for it can be mapped into a model, like a domain. In addition to, it can be mapped to image processing. Yes, sir. I said the abstract. It is about leaf disease detection, where we are going to do a XA concept, where we took a total of 11,216 images from the Kaggle website. It those dataset consist of 4 different crops, namely wheat, mulberry, tea, and corn. Uh, each of those consists of more than 2 classes, where the total data is divided into 3 parts, namely training for 70%, validation for 50%, and testing for 15%, where it is a standard ratio for splitting the data. And in addition to that, we included the hallmark layer of channel shuffle net model, which is channel shuffle layer, and I'll show the working architecture in the upcoming slides. Yes. The goal of our project is to create a machine learning or a deep learning model which is suitable for a low-end devices, and to improve the uh, existing model, we added the channel shuffle layer, which improved the model and gave an accuracy of 98%, compared to other models. A model gave an higher accuracy. And these are the existing models where the traditional visual inspection is a very base model, and basic image classification tools such as an SVG tools is used for predicting the model, and the pre-trained CNN models, which is such as, for example, BGG16 or BGG19, those of size of 750 MB and 800 MB, which is of course not suitable for implementing a model in low-end devices such as low laptops, mobile devices, and in case of drones also we cannot use those big models. And this is the existing methods flow chart, where the disadvantages of existing system is limited to binary classification. Most of the present existing models can classify either the disease is present or disease is absent, where they use a healthy leaves and the disease leaf. And there are also certain scalability issues. For example, model like SBM, we cannot add the data after once the training is done. But in addition to that, there is no interpretability, lack of interpretability. There is no transparency between the model and the user. Where in case of us, we have provided the LIME concept, where the users can trust how a model is able to predict the disease part. And in addition to it, also provides the overfitting risk. The overfitting is a term where the model can perform well in training data, but cannot perform up to that level in the testing data. And this is the proposed methodology. Firstly, I will say what are the algorithms used by us. We chose MobileNet V3 Large, ShuffleNet, SqueezeNet, and RegNet model. These are the models which are suitable for low-end devices, and such as mobiles and low laptops, and even in the small chips. In we choose MobileNet V3 Large as the base model, and we took the hallmark layer of the channel shuffle layer, ShuffleNet model, which is the channel shuffle layer, and I combined those two models, and proposed a new model known as MobileNet V3 Shuffle. And we did this through a brute force method, where all those 4 models are kept as a base model, and the hallmark layer of other models are combined to the base model. From those brute force method, we got an higher accuracy from the MobileNet V3 Shuffle model. And this is the overall workflow of a proposed model, where we took the data set from Kaggle data, where image processing is done to rescale the images to 224 cross 224, where the 224 cross 224 is the base uh, required image input for the MobileNet V3 large model. And the images is split it into 70, 15, 15, which is standard ratio. And in addition to that, the training data is alone augmented to random rotate, resize, or normalize, which is specified in the code. And this augmentation should be done only on the training data, not on validation and testing data. To make our model for real-time use. From that image augmented, we move on to the transfer learning. Transfer learning is about using a pre-trained model and making our images to learn from those models. And from that pre-trained model, we added the channel shuffle layer, which is the enhanced model. From those 4 crops, a total of 17 classes are there, which the T class has six, which is maximum for other 3 classes. From we trained the model for 60 epoch, and we saved the base model and applied Lime on that model. And I like to specify one thing: XI techniques are applied after the model are trained. Once the model is trained, it can able to predict the model, and XI techniques is used to specify how the model is able to predict that disease part. And this is the proposed architecture. I mean, this is the exact block of the mobile net with large pre-trained is represented below, where the channel shuffle layer is added in addition, where finally it gave an 1 cross 1 cross 1280, which is a pre-trained model. And for since 17 classes are used in our model, it gave a 1 cross 1 cross 17 at the final output. Where if we give an image in input layer, it will say which class it belong to from those 17 classes. And the advantages are proposed. Multi-class and multi-disease coverage. As I said, it is a multi-class which consists of more than 4 crop, and it is also multi-disease where one crop contain multiple diseases, and improved accuracy and interpretability. And of course, we improved the accuracy through 98% compared to the other traditional models, and applied the line visualization techniques for interpretability. Real world application. Due to the small size of the model can be deployed easily in mobile devices or even in drones. And scalability and continuous learning. This mobile and with is a model proposed by Google, where the scalability is not a problem. We can add the images as such we can use. And and going on to the results and discussion. During the initial epochs, the loss is higher and the validation is lower, and accuracy is lower. From the at the 60 epochs, we can see that the validation loss and training loss is came to less than 2%, and training loss and training accuracy and validation accuracy gone to 98%. And I like to specify training accuracy gone to 99 and validation accuracy 98, and we got a testing accuracy of 98%. And these are some of the images which applied to the Lime XA concept, where the original image is given as an input, and the model predict it as a class, some class of images. From that class, the Lime technique is used to specify from which part of the image the model is able to identify it as a diseased part. And moreover, we applied this concept to a simple Python app, where we can put the image as an input, and we get the report finally as the output. Yes, ma'am. Thank you, ma'am. Hello, sir.
Hello, yeah, Mr. Jayprakash.
Yes, sir.
Nice, it was nicely presented. I am having one small doubt. Doubt
Yes,
is
sir.
my query that as you said that your model is for the multi-crop, multi-diseases, right?
Yes, sir.
So, is there any chance, any probability of crossing the data between the crop and disease?
Yes, sir. Actually, there is a problem in this multi. For example, most of the leaves will look almost similar, but we need to give more training data such that the model is able to understand the difference between the leaves of different crops. So, by increasing the data set, we can overcome this problem, sir. Hello.
Okay, okay. So means you are saying that we need more data
Yes,
to
sir.
reduce the chances of crossing the data between the disease and crop, right?
Yes, sir.
Okay, thank you. Thank you, Dr.
Yes.
Thank you, sir. Moving on next. I'd like to call Sir for his paper titled on the optimization of resources usage in HPC with a deadline-driven job scheduling algorithm. So please can you start with the presentation?
Okay. Do you see my screen?
So it was visible, now you stopped sharing it. Can you share it again?
Hello?
Hello, sir. Am I audible?
Is it okay? Hello? Do you see my screen?
Yes, sir. It is showing that you have started your presentation, but we aren't
Oh,
able to see your PPT yet.
okay, thank you. Hello, everyone. Thanks for being here today. Now let's start with our proposal. Optimizing resource usage is a key challenge in high-performance computing. So an efficient scheduling is crucial to maximize performance while meeting job constraints. In this work, we focus on a deadline-driven job scheduling algorithm to improve resource allocation, ensuring both efficiency and fairness.
So
So
your
how
screen
Sorry
isn't
to interrupt.
visible.
Yeah.
is not available?
No, sir.
Wow. Please one minute. Okay. Hello.
Sir, if you want, you can send me the PPT in the chat box. I will present it for you. I will screen share it for you.
Richa, I think Santosh Kumar is saying something that he is saying, I think my presentation was done. Can you confirm, please? So, Santosh Kumar's presentation was interrupted in between. So, please decide that whether we need to take again or we can confirm it.
Okay.
I think we can continue, sir. If you have any questions for sir, you could ask him, and then we could move on to this sir's presentation.
I think it was interrupted in between. So,
Yes, okay, fine. Then sir could continue his presentation.
after this or at the last, whatever the suitable for the.
Yeah, after this sir's presentation is done.
Okay, please go ahead. Yes, Mr. D.
Sir, can you send me the PPT in the chat so that I could present it?
Okay. I try.
Or if you want, we can take a presentation at the last if you're facing any connectivity issues or something.
I can send an attached file.
So we can do a thing, we'll move on to the next presentation. Till that time, you can send me, then we'll do yours after him. Does that work for you?
Can you give me an email address to send it?
So you can send in the chat box. Meeting chat box. Meanwhile, Santosh sir, can you please continue with your presentation?
Okay. Without presenting?
So you can send me, and then after Santosh sir is done, I'll take yours.
Okay.
Does that?
Okay. So hello, am I audible?
Yes, sir.
Actually, I thought I was in the meeting, so I was like going with the flow. So I don't know where it got stuck. So can you please tell?
So you can start from the start.
Okay, okay. So am I audible?
Yes, sir.
you are.
And the slides are visible, right?
Yes, yes.
Okay, okay. Sorry for that. Okay, if anything happens, so please let me know in the middle because I can't see the screen. Sorry for that. Okay. So my name is Santosh Kumar, and this is like a dual path autoencoder for graph convolution, giant texture and minutia feature learning in contrast fingerprint recognition is my paper ID. Paper. So this is the contents for this presentation. Introduction, related works.
Excuse me, sir. So can you
Okay.
please continue from where you had left off instead of restarting
Yeah,
it?
that I don't know. Can you please tell here maybe related after
I
related work?
yeah, okay. You can start from there. Continue from there.
Okay, okay. So I'll start from here. So actually,
You start
many.
from the slide 5. You were you were at the
Oh,
slide 5, yes, related work. Go ahead,
okay.
please go ahead with the 6 also.
Okay, okay, okay. So actually, there are some existing works with a combination of minutia and texture feature. So here, but those works are like they are extracting they are not like for specifically for contactless fingerprints. So what they are doing is they are taking the contact-based fingerprint and they're matching with contactless, and then in they are doing such a way in the recognition. So it is not purely for contactless fingerprints. So this is the a research gap. So many existing works either use minutia or texture, or they use like they match the contactless fingerprints to contact based fingerprints, or they use many pre-processing techniques. So are they use many like are they use minutia orientation information, so which is difficult to annotate because there is no orientation information available publicly. So there is no publicly available data set. So so to tackle all those things, we are proposing a method. So I think I'm audible, right? Can you?
Yes, sir. Yes, sir.
Okay, okay. So for the propose, so we are proposing a method where with for extracting the texture, we are using a dual path auto encoder, and for extracting the minutia features, so we are using a graph convolutional neural network. So I'll be explaining the like the feature extraction models differently. So for this texture feature extraction, we are using like two encoders. So the reason is so the two encoders with different kernel sizes. So with different kernel sizes, we can like extract different kind of features. So if the kernel size is more, so it is kind of global feature extraction, and if the kernel size is less, it is like a local feature extraction. And both the features, both that local structure and global structure is combined to extract the texture feature. So you can see the architecture here where we are using kernel size 7 in the first path and kernel size 3 in the second path, and extracting the 256 feature vector. And the same this is decoder is reconstruct the image. So this way, this 256 feature vector is used for texture. And for extracting the minutia features, we will be using a graph convolution neural network, because there are many, there is no specific work on this, and like we believe that the geometric relationship between the minutia points will help the help the accuracy in recognition purpose. So for for extracting the minutia feature, so for using the graph convolution neural network, we need a graph. So for that, we are using minutia location information and extracting the 64 cross 64 patch around it, and using that patch, we are passing that patch to ResNet 18, which is a pre-trained one, and we are extracting the feature called 512 feature vectors. So those feature vectors for each patch, those will be used as node features. And to form the edges, so we are using a KNN algorithm. So using that, we can connect the nodes to some other nodes, and then each node will have a attributes like the distance and the angle between two minutia points. And then that graph is that graph is passed to this GCN, where this 512 indicate node feature. So in throughout the layers, we are not changing the node feature. And at the end, we are extracting the 256 feature vector as a minutia feature with the global mean pool. And then to combine these two features, unlike other, so we are using some MLP which will combine both and give the final feature vector as a 256 vector. So we are using here end-to-end training. So for that, two kind of laws are using reconstruction loss and arc-based loss. And these are the three data sets used in this experiments, that is CFOs, benchmark, and polio. So if you observe here, the benchmark has 1500 individual and polio has 336 individual. But we are not taking everything because there is no minutia information. But so to avoid that, we only picked 100 random individuals, and then we manually label those. So which is giving a benchmark is a 200 images and polio 1200 images. And these for CFOs 140 images are there, and as there are only less impressions for this, less impressions for each finger, so we are using augmentations, so that each finger will have 10 impressions, so that we will be having 7 for training and 3 for testing, and these 3 is used for test recognition results also, recognition experiments also, and this second session data also we are using for recognition. And am I audible, right?
Yes,
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 sir.
you are.
Okay, okay. So for this implementation details, so we are using fourfold cross validation, and we use Adam optimizer with base size 16, and these parameters are used for same parameters are used for all 3 data sets. So basically, first we trained on Polyu data set, and then we fine tuned on both the data sets. Without fine tuning, we are not getting that good results. So we fine tune on both the data sets again. So this is a training setup, and for recognition setup, we need to have genuine pairs and imposter pairs to verify whether our feature vectors are, for genuine pairs, the feature vector should be same in the sense the similarity should be very high. For imposter pairs, the feature vector similarity should be very low. So for that we are forming genuine pairs and imposter pairs. So for genuine pairs, as there are 6 impressions each for Paleo, so we are 6 choose 2 and 100, so 1500 images. And for this imposter pairs, each person is we are taking each finger as one finger, so we can form 100 choose 2. So like that for each data sets, so we are extracting genuine pairs and imposter pairs. So these are the training results we got for benchmark data set. So where you can see that a clear convergence in very less epochs, and here also same case for Paleo data set. So here this is for CFO's data set. Here also it is converged very less because it is having very less images. So these are the recognition results. We can see the ER is very high here, the FAR and genuine acceptance rate. So this is called as ROC curve, where FAR is there, and FAR on x-axis and GR on y-axis. So if I compare my works with other works, so these are I won't say that this is the best method, but it is comparable work, because comparable work, and we are not getting good results because everybody is using like pre-processing and initial location, so both. But here we are using only raw images, no pre-processing, and we are using only location information. So using these two, and we are still getting comparable results. So in where we are getting EER for Paleo 4.08 and benchmark 4.81, for CFOs 8.31. So as a conclusion, so this is the unified approach where unlike some existing methods where they train different branches, so we train here the combinedly, center branch is trained cooperatively. And then like it is there is no pre-processing and nothing, so it is computation wise also it is very less, and it is comparing with other works. And the only thing is this ministry extraction we have manually annotated those. So manually annotating those is very difficult, and this is for less size data set this is okay. So but in the future we are going to develop one a particular algorithm which can give proper ministry locations, and then we can apply this method to large scale data sets. So these are the references, and thank you. Any questions?
Okay, Santosh Kumar, it was a nice
Okay, sir.
presentation, and
thank
we also think
okay, sir. Thank you.
we were not. So one thing which is like in future, how what are your strategies to make this
Strategies to
evidence
make this,
robust for the
sir, strategies to make this feature robust.
huh?
Yes,
As you are saying that
actually,
in future we will work on the accuracy and robustness. So accuracy
yes.
is okay. You can always by, and how you are going to make it robust, and in what sense you are we will make it robust. That is what my query is.
Sir, actually here if we see that the data set we are using very small data set. So we are like having only, because to label this minutia locations manually, it almost took 2 months for my lab, so our teammates. So it is difficult to manually annotate those. So that is why this is only for small data set. So to make it robust, so if we have a large data set, so then we can have the proper like feature extraction. Now here we can see in the training graphs also there are like some kind of fluctuations. So it is actually, and that is why we went for this careful cross validation. The data set is very less. So if we have more data set, so the feature will be more
Yes.
stable, so that it can be.
Make, to make this robust, you not only need the volume of the data set, but you need some of the diversified data set also.
Yes,
Right?
sir. Yes, sir. Yes, sir.
Okay, thank you.
Yes, sir. That is okay. Okay, sir. Thank you, sir.
Thank you for your presentation, sir.
Okay, sir. Thank you.
Yeah. uh, Sir, can you see my screen?
Yes.
Yeah, you can
Yes.
start with your presentation.
Yes,
Okay,
yes.
thank you.
Please go ahead.
Okay. Hello, everyone. Thanks for being here today. Now, let's start with our proposal. Optimizing resource usage is a key challenge in high performance computing. So, an efficient scheduling is crucial to maximize performance while meeting job constraints. In this work, we focus on a deadline-driven job scheduling are going to improve resource allocation, ensuring both efficiency and fairness. Our proposal aim to optimize scheduling by balancing predictability and non-starvation while reducing waiting time. Next slide, please. Today, HPC is crucial because it solves complex problems much faster than traditional computing. It also enables advanced simulation and support breakthrough in science. HPC is also important because processes and analyzes mass data sets efficiently and power large-scale AI model. In this paper, we leverage the flexibility offered by deadline-driven job to design an efficient schedule ensuring predictability and non-starvation with better waiting time than with a well-known conservative backfilling algorithm. Next slide, please. Now let's give an overview of our presentation. We will start with an introduction where we present the context and motivation behind our work. Then we will introduce our deadline-driven first fit backfilling algorithm, explaining how it improves scheduling efficiently. Next, we will give through our simulation results, demonstrating the performance of our approach compared to existing method. Finally, we conclude our work with our key finding and discuss potential results. Next slide, please. HPC is based on resource and job management system to execute a wide variation jobs submitted by multiple users, and there's LGMS such as OA or SLUM, use scheduling algorithms such as Argon extensible scheduling system or conservative backfilling, which are the most used in production center. There's two algorithms guarantee non-starvation, but in the case of easy, there is not predictability. Many work such as fattening backfilling try to improve conservative backfilling and easy. But the problem with fattening backfilling is that there is a risk of starvation and not predictability. Our goal in this work is to rely on bin packing algorithm to design an efficient scheduling algorithm that respects the deadline of each job, so ensuring predictability and non-starvation. Next, please. We designed for that four variants of scheduling algorithm inspired by bin packing algorithm. The first algorithm is based on first fit, uh, uh, first fit algorithm, and the three others are based on first fit decreasing algorithm. Each of these algorithms are based on two key events, such as the arrival of a new job and the finish of execution on a job. When a job, in all cases, when a job finishes execution, all of these algorithms try to execute it while respecting the deadline of the waiting job if there is enough resource available. Otherwise, the algorithm schedule it and add it to the waiting list. When a job finishes execution, the waiting jobs are rescheduled in order of the estimated start time. Each job that can be executed without causing the violation of the deadline of another waiting job is executed. It's important to note that jobs are taken in decreasing order either by the estimated start time in the case of the first algorithm denotes DFF, BF, or by the A. In the second algorithm denote DFF, DBF1, or by the we. In the third algorithm denote DFF, DBF2, or by the area denote DFF, DBF3. Next, please. To illustrate our work, we consider one running job in green and one waiting job, job one, in blue with a deadline D1. And we consider another running job, job two. In this example, you can see that job one can start its execution because it requires more nodes than the available ones. So we try to execute job two while respecting the deadline of a job one. Next slide, please. You can see in this illustration that when we construct job one, its deadline is not violated, so job two can be executed immediately. Next slide, please. Here we present our simulation results. To evaluate our algorithm, we use 4 data sets from the parallel workload archive. The INL data set, which contain about 70,000 jobs. SDSC Blue, 170,000 jobs. And SDSC DS, 90,000 jobs. And HPC2N, around 200,000 jobs. And you can see that before that, we also consider 3 deadlines: 0-hour deadline, 24-hour deadline, and 72-hour deadline. We first conduct a comparative study of the 4 of our variant of algorithm, and you can see that in overall case, DFFD is the most efficient algorithm, and we note that the improvement is particularly significant when the deadline is at least 72 hours. So we can say sorting job in decreasing order does not provide any noticeable benefit compared to a simple first fit strategy. In our case, where estimated execution time are higher than actual execution time. Next slide, please. The second result is the comparative study between our select version DFF-BF and CBF and easy and flattening backfilling. We measure the average wait time when the deadline is set to 0 hour and 24 hour and 72 hour. We observe that the flattening backfilling achieve better performance than easy and conservative backfilling. However, our algorithm consistently outperform the flattening backfilling with a performance gap widening as the deadline increase. Next slide, please. To conclude our work, you can say that easy and flattening backfilling do not guarantee predictability, and flattening backfilling present a risk of starvation. But DFFBF far outperform conservative backfilling, easy and flattening backfilling, And we see that increasing deadline significantly improve the average wait time of submitting job. And also, we know that execution time shows that DFFBF is fast enough because in all cases, we see that the execution time remain under 0.1 second. So DFFBF is fast enough and suitable for production in HPC. For future work, we will do more evaluation of DFFBF by studying deeply the impact of deadline. Thanks for your attention.
Any questions from the session, Chair?
No, I think I don't have any questions. Thank
Okay.
you. All the best, Dr. DJ.
Thank you, sir.
Thank you for your presentation, sir. Moving on next, I'd like to call Mr. Suryanto for his paper titled Post-Purchase Behavior Impact with UTAT. So please can you start with your presentation?
Yes, wait for a moment.
Can you start with your
Yes,
presentation?
can you see my screen?
Yes, sir.
Okay, I will begin. Good morning, everyone. My name is Suryanto, and today I will presenting our research on post-purchase behavior with UTAUD. The study focused on how self-ordering kiosks influence customer behavior after making a purchase in a fast food restaurant. Through this research, we aim to understand what factor encourage customer to continue using this technology and how it impact their satisfaction and loyalty. I will begin the presentation. Next. Today in this presentation, I will explain about introduction, literature review, methodology, result and discussion, and conclusion and future research. Next, please. Indonesian restaurant industry is valued at around 36.8 billion US dollar, and it keep growing rapidly. Rival among business has become more intense. To keep up, fast food restaurants are turning to self-ordering kiosks to improve service efficiency, minimize waiting time, and enhance ordering accuracy. Although self-ordering kiosks offer a more seamless and independent ordering experience, some customers may still be clueless to use to them due to unfamiliar or prefer traditional service. The study applied the UTAUD model to analyze how self-ordering kiosks affect customer behavior after purchase, particularly in the terms of satisfaction, continued use, brand loyalty, and recommendation to other people. Understanding this long-term effect can help business optimize their approach to self-service technology adoption. Next, Will. So now let's talk a bit about UTAUD, which stands for Unified Theory of Acceptance and Use Technology. In simple terms, this model explains why people decide to accept or use a new technology, especially in the business or workplace setting. Performance expectancy. Customer believe self-ordering kiosks make transaction faster and easier. When they see a clear benefit like shorter wait time or like a smoother ordering, they are more likely to use them. Previous studies show that usefulness strongly influence adoption decision. Effort expectancy. If self-ordering kiosks are simple and user-friendly, customers are more willing to use them. A smooth interface with a clear instruction help increase adoption. Research suggests that each of use is more impactful than social factor when deciding to use a new technology. Social influence. People may try self-ordering kiosks if friends or family or social trend encourage them, but conviction is a more stronger factor. Study indicate that while recommendation can help, user prioritize efficiency over peer influence. Next slide. Facilitating condition. So having a good infrastructure, reliable system, and clear guidance make self-ordering kiosks easy to adopt. Technical support and accessibility such as a user assistant or system reliability play really crucial role in terms of encouraging continued usage. Hedonic motivation. It's referred to the enjoyment of or a pleasure gained from using self-ordering kiosks. While the fun aspect can encourage adoption, customers often prioritize efficiency over enjoyment when making their choice. Price value. Customers assess whether the benefit of self-ordering kiosks justify the cost. So if using them lead to saving or exclusive discount, adoption rate increase. Promotion, promotion offer and price advantage make them more attractive to user. Habit. The more frequent customer using the self ordering kiosk, the more natural it's become for them. Regular users tend to prefer self-ordering kiosks and are less more likely to switch back to traditional ordering method. Post-purchase behavior. Customer satisfaction after using self-ordering kiosks influence whether they will return. Positive experience encourage loyalty and repeat usage, while the negative interaction may lead to complaint. Usually, next bill. To analyze customer behavior after using self-ordering kiosks, we use the UTAUT framework, as you can see, which help identify key factor influencing technology adoption and continued use. This study examined 7 factors, which is performance expectancy, effort expectancy, social influence, facilitating condition, hedonic motivation, price value, and habit. Next, please. This study focused on the factor influencing post-purchase behavior. This purpose hypothesis include performance and effort expectancy, social influence, facilitating condition, hedonic motivation, price value, and habit, all of which are expected to have a significant impact on consumer decision after make a purchase. By testing this hypothesis, we aim to find out which factor has have the stronger impact on customer behavior after using self-ordering kiosks. The result will help business understand what make customer continue using self-ordering kiosks and also how they can improve their service. Next, please. So to ensure a reliable result, we use a
Excuse
structure.
me, sir.
Yes.
Sorry to interrupt. 9 minutes are over. So can you please wrap up?
Oh yeah. Okay. Okay. I'll keep up. So this study used a quantitative approach with purposive sampling method targeting 400 respondents who are fast food customers using a self-ordering kiosk in Jakarta. Next, Will. So this demographic data show a balanced gender distribution with most respondents in their predicted age. In terms of occupation, this majority work in private sector or run their own business, while students make up a smaller portion. This indicates that that the preference of and behavior of study are more related to working individual than to the student. Next will. So to test the impact of different factors on post-purchase behavior, we conducted hypothesis testing using the 7 factor from our research framework. This result show that the most factor has significant effect, meaning they influence whether the customer using self-ordering kiosks. This finding highlight that customer prioritize conviction, ease of use, and external influence rather than fun when adopting this technology. Next, Will.
Okay, you just come to the conclusion and result, please.
Okay. Sorry. So the conclusion is self-ordering kiosks improve post-purchase behavior by offering a faster and easier ordering experience. Customer prioritize efficiency and reliable over fun. So business must ensure self-ordering kiosk is user-friendly and well adopted. However, this study has more limitation. Like it's only focused on a fast food restaurant in Jakarta, excluded other factor, and was conducted in a short time frame, meaning long-term trend were not fully captured. So that's all for that's all our presentation. Thank you for attention and have a great day.
Okay, Suryanto and William, it was a nice presentation. Are you studying some course in the university?
Sorry.
Are you pursuing some course in the university in hotel management?
Yes.
Yes.
Okay. So this research is showing that you have taken the 400 as a sample size, and your 57% data is below 30, right? So
Right.
more you can say that it is the post-purchase behavior of youngsters rather than there are several population, right? Is there any specific idea to select in that way, or this is just the random sampling by which you are getting this data like 57% is the below 30, or it was the idea of your research? Are you able to getting what I'm saying is, Suryanto? Okay, so Charlie, all the best. Do some more work on the research sampling, right? Thank you.
Thank you, sir.
Thank you so much for the presentation, sir. Moving on next, I'd like to call Ms. Debalina Barik for her paper titled Role of Gen AI in Fake News Creation and Detection. Ma'am, please can you start with the presentation?
Yes, ma'am. Good morning, everybody. Just give me a moment.
Yes, ma'am.
We have one more presentation after this, right?
Yes, sir.
Ma'am, is my presentation visible?
Yes, ma'am.
Okay. Thank you. My paper is on role of generative AI in fake news creation and detection. I am Debolina Badi from Kolkata. Now, what is generative AI? Generative AI has in recent scenario has made very various progress in various industries. And in case of adversarial networks, generative adversarial networks and transformers, they have enhanced its capabilities for generating human-like text, appropriate images, and audio according to inputted query. Generative AI works by starting with a prompt, which can be in the form of text, images, audio, or synthetic data. And then it can process the AI system and can process human-like generation of the text, images, audio, and synthetic data. Various AI applications then generate new content and response to this prompt. These algorithms include natural language processing techniques for text generation and image processing techniques for image generation. Now, what is fake news? Fake news can be classified into two categories. One is misinformation and another is disinformation. Misinformation is false or misleading information spread unintentionally by the users, and disinformation is false information deliberately created to deceive the users. It affects public opinion, manipulates elections, and it has a very big role in assessing the eternity of the people. That fake news has many drawbacks, but I am dealing with fake news, how to deal with fake news in this recent scenario, that is in the age of generative AI. There are various applications of generative AI, such as content creation. Example, the ChatGPT, Jasper, DALL-E, Midjourney, and OpenAI's Museness, etc.
Hello,
You are,
ma'am. Are you
you are
speaking?
mute, Madam Debelina. You are mute. Please unmute yourself and then go ahead.
Yes, ma'am. Shall I start with this slide?
Yeah, you can
You can
continue.
continue. Yes, ma'am.
So there are various applications of generative AI. Generative AI has a wide range of applications across various industries. Some of the applications are content creation, example, ChatGPT, Jasper, DALL-E, Midjourney, OpenAI, and Museness. Healthcare and medicine, it has, for example, DeepMind's AlphaFold is an app for this healthcare and medicine. Software development and AI coding, GitHub, Copilot, and OpenAI is used as apps. Marketing and advertisement, example, chatbots and virtual assistants are used. In business and finance, like stock market predictions, automatic AI is used to automate the process. Education and training, AI-driven virtual reality and augmented AR is used. And science and research, example, DNA and protein sequence generation is used. So in cyber security and defense, it is used as fraud detection, threat detection, or deepfake detection. Now, the role of generative AI in fake news creation and detection. There are various models in generative AI like transformers, GANs, GPTs, autoencoders, and variational autoencoders. So in fake news creation, mainly the creation of text generation, audio generation, image synthesis, and video generation is done using generative AI. And for fake news detection, the social media analysis, crowdsourcing, and content verification is done using generative AI. Generative AI in fake news creation. Generative AI models such as GPT, DALL-E are capable of generating high quality, convincing text and imagery, and also audio and music generation, multimodal AI. These are used for generation of automated music, and multimodal means there are many different modes where we use this generative AI. Generative AI and fake news creation, deepfake technology, AI generated images, video impersonating real people often used for political misinformation. For example, deepfake videos of politicians saying things that they have never said. Some pictures of politicians, they were not present in the meetings or something. These deepfake technologies can be detected using generative AI and fake news creation. Now, AI-driven text generation, language models like GPT can write entire news articles with fabricated content. This raises serious ethical concerns about the misuse in creating disinformation, which can influence public opinion, intensify societal divides, and impact political outcomes. Generative AI and fake news detection. In this case, natural language processing we use for text analysis. AI detects inconsistency in the text, sentiment manipulation, and text narratives. For example, identifying misleading headlines through AI-based sentiment analysis is done for fake news detection. Now, deepfake and detection models are also used by analyzing patterns, pixel inconsistencies, and audio mismatches. Example, Facebook, Microsoft deepfake detection initiatives. We can use these fake news detection models. Models of generative AI. The first model is generative adversarial networks. Generative adversarial network consists of two neural networks, the generator and the discriminator, which are trained together to an adversarial process. The generator produces fake content and the discriminator evaluates the authenticity of the generated content. The generator iteratively improves its output to create realistic results through an adversarial training process. AI architectures that generate hyper-realistic images, videos, and audio comes in this generative adversarial network form. The second is transformers. Models such as GPT-3 utilize transformer architectures and attention mechanisms to understand context and generate contextually accurate text. Transformers have revolutionized natural language processing by excelling at tasks like text generation, translation, and summarizations. Generative pre-trained transformers, the third one is GPTs. These are large-scale language models trained for text-based content creation. The fourth one is variational autoencoders, VAEs. VAEs encode input data into a latent space representation, then decode it to generate new content resembling the original. This approach is commonly used for generating structured data and including images and audios. Moving to the next slide. Why does generative AI is effective in spreading fake news? Because in using generative AI, the speed and volume of the distribution of news becomes in an unprecedented scale. And if we can generate a huge volume of news, but those news has to be authenticated by the sources, then only we can use those news. Human-like content, AI-generated text, images, and videos are often indistinguishable from real ones. That's why it is very hard to distinguish fake news from the original news. Accessibility, open source AI tools enable widespread of use of malicious informations, but we have to be careful in using these open source AI tools. Social media messages, AI-powered algorithms promote engaging, often misleading contents. And this social media like Facebook, LinkedIn, WhatsApp, social media, LinkedIn, WhatsApp, Facebook, these are used to create, to promote this generative fake news, and also to get a clue that how this generative AI is going to affect in the future generations. Generative AI and fake news. Generative AI produces synthetic content that appears to be legitimate It raises ethical questions, plays crucial role in detecting and mitigating in misinformation. Crowdsourcing and content verification approaches help to combat the spread of false narratives by detecting inconsistencies in information. Coming to the conclusion of generative AI and fake news, on one hand, advanced AI models such as generative adversarial networks and large language models enables the seamless generation of misleading text, images, audio, and videos, making it impressively difficult to distinguish between real and synthetic content. This has raised significant concerns about misinformation propagation, deepfakes, and the erosion of public trust in digital media. On the other hand, the same advancements in AI have also led to the development of many detection methods. Techniques such as NLP, machine learning classification, deep learning models, and AI-driven verification systems are being used to identify, analyze, and mitigate the spread of false information. To effectively combat the second conclusion, coming to the second conclusion, to effectively combat AI-generated misinformation, a multidisciplinary approach is essential in bringing together AI researchers, policymakers, social media platforms, and the public. And lastly, AI advancements have challenged the spread of fake news and the integrity of information in this digital age. Our research will be helpful for new researchers working on generative AI and the effect of fake news generation and detection. Thank you all. And if there is any questions, I will be happy to answer.
Okay, nice presentation. It was, Madam Devalina. As you are saying that the generative AI is the responsible to generate the fake news, and we need some of the monitoring as well as some regulations for that.
Yes.
Recently, the ChatGPT has introduced one feature, ChatGPT, for the students, right? It is
Yes.
like GPT plus for the student from my group. So if we think that the generative AI tools like ChatGPT and others are making some fake news or misleading information, so what is the government's concern about that, and how they are implementing such things, that because now they are it is free from the students, but they are generating the manpower with that. May that manpower have some of the misleading information, they may generate some misleading knowledge for that, and overall they can malicious the entire wisdom. So what you suggest, on the basis of your research, what do you suggest that the how government can make control over the fake news creation by the generative AI tools?
The government can make policies, and the policies for cybercrime has already been made by the government. Cybercrime laws has come upon. Like that only, for generative AI generation, government can make rules so that the fake news is not spread to a greater extent. And you cannot stop the spread of fake news until and unless the people are aware of the very fact that the news is fake or real. So fake news in the government policies can be made, and laws can be made where government can detect the fake news and give some punishments for the people who are spreading such fake news.
Law are already there, you know.
Yes, some
ICPTA
laws are
and all
already
laws are
there.
already there. IT Act is there, cyber laws are there,
Yes,
but
yes.
still the things are increasing with the what speed. Its growth is very high. So,
Yes, sir.
what do you suggest? What extra efforts can be done by the government to governance these things? Means to stop the fake news creation or spreading or something by involving these social media platforms too.
Yes, sir. In social media platforms, they can, means government can restrict the spread by using some tools where they can see the news is actually fake or not, or real or not, from the source that they have been taken. So from if the government tries to see whether the news was real in published in paper or any news channel, they can verify it, and after that they can promote that news to the social media platforms. Not before that, means people directly cannot post the videos. They can go through the government can take a initiative where they will be allowed to go through the government, and then only they can post the videos and images.
Okay, good. So I wish you all the best for this kind of research and more suggestions to government based on your research. Thank you, Devalina. Thank you. Okay.
Thank you, sir.
Thank you, ma'am, for the presentation. Um, Moving on next, I'd like to call Mr. ZV Song for his paper titled Witchformer, a transformer-based multimodal fusion framework for harvest date prediction and control. So can you please start with your presentation?
Hello, can you see my slide?
Yes, sir, it's visible.
So is that correct in the sharing model?
No, sir, you can continue. It is visible.
Okay. So hello everyone. So I'm very happy to here to introduce my paper with former a transformer-based multimodal fusion framework for heavy state prediction and control. And I'm come from the University of Yamanashi, Japan. So my name is Song Ziwei. Next is here is the outlines of my papers or my presentations. I would introduce our works in the following part. So first is like the motivation. Actually, as we can see that the price of the vegetable is changed quite quite fast depending on the demand of the market. Like in the festival seasons, the price of the vegetables or the fruits is quite high price, and when it's come to the summertime or some other fruits time, so the price will dropping. So for the farmer, so we need a kind of like arrangement for the harvest day or some other take some schedules to arrange the harvest time to meet the kind of like the market to get the highest interest to get the paid. Like however, like early harvest day prediction is like by man is quite difficult, and also for some like experiments, the farmer is like they just like inferred that harvest time is like quite like within 5 days. It's not quite precise. And another thing is like it's quite hard for the humans to analyze quite such big data. So our our goal is like want to give a quite model to give the prediction of the harvest of the vegetables. But before we go that, so I'd like to introduce some related work. So the first one is like the eggplant optimal harvest date prediction with the sensor data. So like what they have done is like they take advantage of the some sensor data like the temperature and the CO2 and some others like flower ID, harvest data, and weather data, the maximum and maximum temperatures of the days. This is what they done. Another related work is like called the apple harvest date prediction with sensor data. So this kind of research is like similar like previously using the sensor data. However, they using like different growing period and also different like life circle in the relation seasons and then giving the different harvest date predictions. So the third one is like the tomato harvest date prediction within the image data. So quite different with the some previous research is like they using the image as the input data to get some prediction like the 4 days or 3 days, 2 days before the mature. So motivated by those. Here is kind of like conclusion of all those three works. So as we can see, like here, the result is like all those prediction is like 3.9 or 2.3 is like 2 or 3 days kind of like difference with the accurate harvest day. And also for the data that they used is like one is like using the sensor data, and also for the apple they using like the life circle data, and also for the tomato part is like they using image data. So however, the accuracy is like not quite high. So what we want to do is like predicting the harvest data earlier. And here is the proposed method. We take advantage of all the data set, the data part that they used before. So we're using both sensor data and the image data. So we got two branch. One branch is for the image processing. One is like after we feed this image processing into the feature extractor, then flatten it, and also for the sensor data, we also feed it in the same feature extractor, get such like sensor data extend features, and then concat it and feed those kind of like features into the multimodal fusion transformer to, and then we put the output of the multifusion transformer into an MLP to get the predicted the remain harvest days. Another is like beside that, we also predict another one is like called adaptive harvest control, which means that we can like controlling the futures like green winter's temperature and the sea, so how many days it will be a harvest. So the difference between the adaptive harvest control and the harvest maturity prediction is like we got another branch, so which is called like future sensor branch. So in this branch, like we not only give the future temperature like the maximum and minimum temperature data, and also the sensor data simulations, and also the historical temperatures, which is like quite helpful for the model to predict the future thing. So the data flow is like quite similar, but only this like additional branch is added to control the harvest day. So here is like the input data structure. So first we got the historical sensor data, like how many days it's before the from now to the seeding data, and also the vegetable images. So we put a camera just like on the side view of the vegetables in the greenhouse, and also the future sensor data. It's like next 60 days of the future data. So all those is like or are feeded into the models to control the harvest day. So here is like how we get the data. First, we set the camera like this. This we capture the growing of the komatsuna. So then we collect the different days of like growing of the vegetables. Then the sensor data that we get is like we in the greenhouse we put 4 sensor temperature sensor data, and also one like
Excuse me, sir. Sorry to interrupt, but time's already over. Can you please wrap up?
okay. So we got just to add some like sensor data inside the greenhouse. Then we got this kind of like sensor data, and for the future data is like include maximum temperature, minimum temperature, and simulated sensor data. For simulated sensor data is like we're using the last year's data and just using the extract the base the same data, ignore the year, and we treat this last year's data sensor data as the simulated data. And here is like kind of result of the harvest maturity prediction. So from here we can see that the MAE is like 2.0. So it's like outperform the kind of like three last researches. And also for the remain harvest disk control, we can see that the adaptive harvest control is like the performance even better than the prediction models, like because we add some future data, another branch, so we can get more information. And here is like try to control the harvest data. So like here is like the original ground truth, and this is like these three different line is like within different temperature. Here this orange one is like nothing added. The green is like we add 5 temperature higher, and the other is like 10 temperature higher. We can see that the predicted remain harvest state is like quite the difference. So the higher temperature, there will be like faster days for harvest. And here we also do some ablation studies to try to get some different data combination to get the best results. And the historical and the current data image and the future sensor data reach the best ones. And here is the conclusion. Like we proposed Widgeformer, which is like transformer-based multimodal framework for predicting the remain harvest days of Komatsuno. And the model fusion is achieved by integrating historical and the focused sensor data with real-time crop image. Another is like the model can prove that it can predict the harvest control by utilizing the future environment data. So yeah, that's all from me. Thank you for your listening.
Thank you, Songji. It was nice presentation, and this time I do not have any query, but I would like to state that you are implementing the technology in the agriculture field, and thank you so much for all the best.
Thank you.
Thank you for your presentation, sir. So I'd so one last call for Mr. Kuok BUI. Sir, sir, are you there in the meet? I believe sir is not there in the meeting, so we could continue. I sincerely thank all our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 9th versions and all the previous 8 versions of this conference. We'll be happy to have you in the 10th version in 2026. All the presenters would be giving their digital certificates via mail within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication would be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I'd also like to thank our session chair, Dr. Paras Kothari sir. This is a token of appreciation. This is a token of appreciation on behalf of the team ICTIS 2025 and Global Knowledge Research Foundations and partners. Thank you, sir, for your valuable presence. Now I'd like to request everyone to please switch on your cameras for a quick snapshot. Thank you, everyone. Have a nice day.
Thank you, Richard. Thank you, everyone. And
Yeah, thank
please
you.
share this photograph also on the mail.
Sure, sir.
Photograph. All the best, researchers. Good luck. Thank you very much. Namaskar.
Thank you,
Thank
sir.
you.